Hello everyone. We have now moved into module 4 unit 2, design of clutches and brakes. In this video we look into the designing aspects of a clutch. This is an introductory video that speaks largely about the design factors, the functioning, and the theoretical aspects regarding a clutch. As you can see in the animation that is shown here, a clutch is used to obtain a temporary brake between the driving element and the driven element. All right. So we will learn more about the functioning of a clutch and its design factors in the next slides. So let's begin. All right. So what is a clutch? A clutch is a mechanical device which is used to connect or disconnect the source of power from the remaining parts of the power transmission system at the will of the operator. That is, we have all extensively used clutches in our automobiles, right? Now, before you want to shift your gears, what will we do? We will press the clutch pedal. And what does that do? That will disengage the engine power and the transmission system, right? And therefore, we are free to shift the gears, right? Therefore, a clutch is used to obtain that temporary disengagement between the prime mover and the transmission system. That is the primary use of a clutch. Now, we often use terms such as couplings, clutches, and brakes. Okay. Now, these three are very similar machine elements. Okay. A clutch and a coupling are used to obtain a connection between the driver and the driven shaft. Okay, the difference between both is that uh, while a coupling is more of a permanent or a fixed connection between the driver and the driven shaft, a clutch has got an option of uh, providing a temporary disengagement between the driver and the driven shafts. Whereas a brake we know is used when we want one of the two shafts to be brought to rest. Okay. All right. So clutches can be described further with respect to its initial and final condition. Initially, when you press the clutch pedal, the driving member will be rotating. That is, your engine shaft will still be rotating, but the transmission system or the driven member is at rest. Right? Therefore, actuating the clutch will cause the uh, driven member to be at rest. Okay? And finally, when you will release the clutch pedal, or the clutch plates will now be like engaged, both members, both the driver and the driven shaft will rotate at the same speed and they will have no relative motion. Right? So this is how a clutch works. So let's move on to the next slide. Okay, so in this slide, we look at the four classification of clutches. They are positive contact clutches, then you have friction clutches, then you have electromagnetic clutches, and then you have fluid clutches. Right? So these are the four general classifications. I've got photographs of all four groups. Let's have a look at it. Now, this is the figure of a positive clutch, right? Where you can see that you have jaws on both the plates that are mounted on both the driving shaft and the driven shaft. And when these jaws are in mesh or when these jaws are engaged, both the driving and the driven shaft behaves like a single unit and they will be transmission of power. But when you press the clutch pedal and when both the jaws are separated, there will no longer be transmission of power and you will get that temporary break, right? Now we make use of helical compression springs to make sure that the engagement that the jaws are in like engagement. Okay. Next, we look at the figure of the friction clutch. The friction clutch are very popular in use, much popular than the positive clutch, right? Now, friction clutch, uh, as you can see, you have two plates here, one plate each on both the driver and the driven shaft. When the clutches or when the clutch plates are in contact, because of the friction between both, it will behave as a single unit and there will be power transmission. When you press the clutch pedal, they will be separated and there will be a temporary break in transmission of power. Now, the transmission of power happens because of the friction between the two contacting surfaces, hence the term friction clutch. Okay. Uh, Third one is electromagnetic touch, where the engagement and disengagement is obtained through the use of magnetic field. All right. Then we have fluid clutch, where the engagement and the disengagement happens because of fluid pressure. Right. So this is how both the all four categories of clutches will work. Now, in the next slide, we will look into a comparison of all four categories of clutches. All right, so in this slide, I've made a comparison of all four categories of clutches. You have positive contact, friction, electromagnetic, and fluid. I want you to go through them in detail. In positive contact, as I mentioned, the main like advantage is that since there is a positive like engagement, there will be no slip. Hence, large torque can be transmitted. Uh, in friction clutches, the power transmission is achieved by means of friction between the two contacting surfaces. Electromagnetic touches work on magnetic field, right? And the main like advantage of electromagnetic clutch is the very fast response period. Okay? And fluid clutches works on hydraulic pressure. Okay, and again, one of the main like advantage of fluid clutch is that uh, it provides for a extremely smooth like operation, and because of the use of fluid, it will function as a shock absorber also, right? So this is a comparison between all four categories of clutches. Now we move on to the next slide. All right. In this slide here, I've given a link for a online animation of how a clutch works. It is uploaded by Simon Racebeck, and I would want you to go through this animation so that you are able to visualize the functioning of a clutch much better. All right. So please make use of the PPT and click on the link, and you can go to the animation video. All right, so this slide here gives us one more online resource on a simple a plate clutch or a friction clutch, okay, single disc friction clutch, and it speaks about the manufacturing aspects of a friction clutch also. All right, so please use this link, visit the video, and learn from it. All right, let's move on to the next slide. All right, so in this slide, we look at a comparison between positive contact clutch and a friction clutch. Primarily, we will be looking at the like advantages and the drawbacks. We will begin with a jaw clutch, which is a positive contact clutch, and the two main like advantages is that because of the positive like engagement, there will be no slip, and there is no heat generated in this clutch because there is no friction like involved here. Like, therefore, these are the two main like advantages of jaw clutches. And the drawbacks or disadvantages of a positive contact clutch is that they can be engaged only when the shafts are stationary or are rotating at very small speeds. Because when they are running at high speeds, it becomes difficult to suddenly engage both the jaws because there will be a sudden shock like involved which may damage the transmission system. So let's look at like advantages and drawbacks of friction clutches in the next slide. Okay, now we will look at the advantages and disadvantages of friction clutches. In case of a friction clutch, the engagement is smooth. Okay, when you are driving, like instructor told you to release the clutch pedal very smoothly or very slowly. What he intended was to have the clutch plates getting into like engagement in a very gradual or smooth manner. Therefore, we are able to achieve the smooth like engagement with friction clutches. Uh, and with friction clutches, there will be slip, and the slip is largely limited during engagement only. And once the clutch plates are engaged, there will be no slip. Okay, and power loss and heat generations, while they do exist, is not severe. Only if the catches are very frequently like operated. Especially when there's very frequent start and stop, you may have larger loss in power. Other than that, even friction catches does not offer much of a heat generation or loss due to friction. Okay. Uh, and one of the main like advantages of a friction clutch is that at some certain like occasions, it serves as a safety device. That is, in case if the power exceeds the safe value, the friction disc will slip, because of which damage to the transmission chain is prevented. Right? Therefore, the nature of like operation of a friction clutch has got a certain safety net to it. Right? Okay. So let's go on to the next slide. Okay. So here I have just taken out the schematic of positive clutch and a friction clutch from Bandari textbook, okay, for your reference here. Now this figure here shows a square jaw clutch here. This is the jaw and the a socket here. Now when the jaw and socket are like engaged, there will be transmission of power. When you need to have a disengagement, you will press the clutch and you will have a disengagement. Okay, this is the shift lever that you see here. Okay. And this is the schematic of a friction clutch, single plate friction clutch, where you have a drive shaft and a driven shaft. Plates are mounted on both here, and you can see that on the drive shaft plate you have the friction lining. Now, when the clutch is engaged, there is a separation here and there is no transmission of power. When the clutch pedal is released, both surfaces will be in contact, because of which there will be transmission of power. So let's move on to the next slide. All right, now we will look into classification of friction clutches, because in our syllabus, friction clutch is the main aspect. So we will be looking into both single plate and multi-plate friction clutches, right? So depending upon the number of friction surfaces, the friction clutches, as we mentioned, are classified into single plate and multi-plate. All right, so and depending upon the shape of the friction material, friction clutches can also be categorized into disc and cone clutches. And there is also something known as expanding shoe clutches, right? So these are the three categorization of friction clutches based upon the shape, and based upon the number of friction surfaces, we have single plate and multi plate. All right, so this slide here provides the various factors to be taken into account while we design a clutch, right? So there is a whole lot of factors to be taken into account. I would want you to go through it in detail. Uh, you can see that application, you need to take factors such as application into like account. The friction material is again an important decision to be taken, and one of the most prominent factors involved in the design is the torque transmission capacity. Okay, the amount of torque that needs to be transmitted is probably the most important factor to be taken into like account, right? Then you have shock absorption and means of like engagement, low weight, and compensating wear, right? And heat generation. All these are design factors like involved in friction clutches. All right. So as I mentioned previously, the most important parameter that we have to look into is the torque carrying capacity of the friction clutch. All right. So there is a derivation like that you will have to learn. That is, we need like equations to calculate what is the torque that can be transmitted by a given friction clutch, right? So this derivation is like important. uh, I have taken it from the Bandari book, and I have presented it for your reference. Now please use it and study the derivation like involved. If you see this figure here, a friction disk is shown here, and the and the notations are as follows. Capital letter D that you see here is the outer diameter of the friction disk. Small letter d is the inner diameter. Small letter p is intensity of pressure at a given radius r, right? And capital letter P is the total like operating force, right? So these are the important parameters that we need to look into like account. That is, if you will see this figure, at a radius r, we take a small like element dr, and we will calculate the torque at this small little like element, and then like integrate it for the entire friction surface. All right, so let's move on to the next slide. Okay, so moving on, we have now like assumed that there is an intensity of pressure P at a radius r, where we will take an like elemental ring of thickness dr at a radius r, and for this ring that you see, the area will be the circumference 2 pi r into the thickness dr. That will be the surface area. Okay? And then what will be the force? If small letter p is the intensity of pressure that acts on the small ring, then force we know is pressure into surface area. Okay? Therefore, it will be pressure p into surface area 2 pi r dr. Now, rewriting this, you have, if you take the 2 pi outside, you have 2 pi into pr dr. I will name it as equation A. Right? Now, uh, like elemental friction force, when the two clutch plates are in uh, contact, right, the friction force will be obtained by multiplying the axial force with the coefficient of friction mu, right? Therefore you have mu p into 2 pi r dr, area into friction force, right? So will like give you the friction force that acts on this like elemental ring. Okay. Now, what is torque? Torque will be force into perpendicular the distance here. Now here the perpendicular distance will be the radius r. Force we already have calculated like above. Therefore, mu p 2 pi r dr is the force. Multiply by the radius r and you will get the elemental friction torque. That is the torque that acts on this small ring. Alright. Now, rearranging, you will get, if you take the constants like outside, you will get 2 pi mu into pr square dr, right? Which I will name it as like equation B. Right? Therefore, you have got the equation for torque at the elemental ring. So let's move on to the next slide. All right. So having got the formula for torque of the ring, we will now integrate it for the entire contact surface. That is by like integrating the above like expression A, you will get that is integral of 2 pi pr dr, right, for the force, for the total axial force P. You will take out 2 pi like outside and you will integrate pr dr. Okay. Similarly, we can integrate it directly for the torque equation like also. Okay, and you will get the net uh, torque that acts over the entire contact surface is 2 pi mu into integral of d by 2, that is inner radius to outer radius pr square dr. All right. Now, from these two like expressions, that is uh, equation 11.1 gives you the total force P and 11.2 gives you the torque mt. Right now, what we are interested in is to get a proper equation for the torque that can for to the maximum torque that can be transmitted by the clutch plate. Right now, uh, there are two theories which are used to obtain the final torque capacity of the clutch. They are uniform pressure theory and uniform wear theory. Okay. Now we will use these two theories, substitute them into formula 11.2, and you will get the torque carrying capacity formula for the clutch, which we will see in the next slide. All right, so let's look into the first theory, which is uniform pressure theory. Now, uniform pressure theory is largely applicable for new clutches. Okay, when the clutch is new and when the pressure can be assumed to be uniformly spread over the entire contact surface, we can assume that the P is the pressure, the intensity of pressure P is constant, right? Therefore, from equation 11.1, see in this figure, if you will observe figure A, we can say that the intensity of pressure is uniform across the contacting surface. Right now, if you will look at the force equation which we had previously seen, and if you will assume pressure P to be constant, we can take out P. We can move P to the outside the like integral and carry out the like integration, and you will get the formula for force, the axial force, as pi P by 4 into d square minus small letter d square. Right? Now this is the formula for the force. Now we will look into the moment equation or the torque equation in the next slide. All right, so similarly, we will take the torque equation on the ring and you will like integrate it now. And since pressure is a constant, since we are dealing with uniform pressure theory, we will take out P and then carry out the like integration, and you will get the formula for the torque as pi mu P divided by 12 into d cube minus d cube. Now this is the formula for torque, and if you will divide uh, equation 11.4 by 11.3, that is torque by axial force, if you will divide both, and take force to the right hand side, you will get the final formula for the torque carrying capacity as mu p by 3 into d cube minus d cube divided by 3 times d square minus d square. This is the formula that we will be using to calculate the torque carrying capacity of the clutch using uniform pressure theory. Remember that we started off by saying that uniform pressure can be expected only in new clutches. When there is very less wear and the pressure can be assumed to be uniformly spread across the contacting surface, this equation is valid. Alright, so the above formula have been derived for a single pair. Right, that is in the figure if you see, this is derived for a single plate of uh, single plate clutch. Now when there are a multi-plate, when there are more than two plates like involved, okay, then we should multiply this uh, RHS by number of pairs of contacting surfaces, right? So that we will see in the slide where we will deal with multi-plate, right? So this is the formula for uniform pressure theory. Now we will look at uniform wear theory in the next slide. All right, now moving on to the second theory of uh, patch plates, we look at uniform wear theory. Now, according to uniform wear, it is assumed that the wear is uniform across the surface area. Okay, hence we normally use uniform wear theory for clutches which are not very new, which are, that is for clutch plates which are already worn out. All right, uh, unlike uniform pressure which was for new clutches. Right, now if you will look at the figure here, you can actually see that the pressure is no longer uniform here. Right, now as you can read here, the axial wear of the friction disk is proportional to the friction work, right? And we know that the friction work is uh, frictional force mu p into the rubbing velocity, which will be 2 pi r into the number of revolutions n, 2 pi r n, okay, where n is your linear speed or rpm, revolutions per minute. Right, now we can state that the wear is directly proportional to the uh, frictional is proportional to the work done, which is frictional force into velocity. Okay, now assuming speed n and the coefficient of friction mu as constant, we can take them both outside, and we will then obtain the formula as where is proportional to P into R, right? Because mu and P is constant, therefore where can be assumed to be directly proportional to P into R, right? Now when the where is uniform, PR is equal to constant. The pressure, the distribution you can see here in like figure B. Okay? It is no longer uniform, and we will see the formulas in the next slide. All right, now moving on, if you will have a look at the figure here. Now as we mentioned, in case of uniform wear, the pressure is not uniform. In fact, we can see that there is a inverse relationship between radius and intensity of pressure. When the radius like increases, the pressure decreases. Okay, and you can see that maximum pressure as is at the inner radius, and then the pressure will drop to the outer radius. All right, now if I will assume the maximum inner pressure to be PA, right? And since in case of uniform wear, we have seen in the previous slide that where the product P into R is constant, right? And we will denote P as PA, and The radius we know is d by 2. Okay. Now substituting it back into the force equation 11.1, we can integrate it and we will obtain force as pi PAD by 2 into d minus d. Right. Similarly, by substituting PR equal to PAD by 2 into the torque equation, you will get the torque equation as pi mu PAD by 8 into d square minus d square. It's simple, straightforward like integration. Okay. All right. So dividing torque by power equation, we will get the final torque equation as mt is equal to mu p by 4 into d plus d. This is the torque equation for uniform wear theory, which is largely applicable for worn out clutches. All right. So the above formula is gives the torque transmitting capacity. All right. Okay. Now, if you will summarize what we have derived so far, the two torque carrying capacity formulas are: for uniform pressure, you have mu p by 3 d cube minus d cube divided by d square minus d square, equation 11.5. And for uniform wear, we have what we have just now obtained, mu p by 4 into d plus d. These are the torque capacity formulas for uniform pressure and uniform wear. All right. Now, it is important to note that the wear in clutch plate happens in two stages. Right. When the clutch plate is new, that is when the friction lining is new, then we know that uniform pressure theory is now like applicable, because pressure will be uniform across the uh, contact surface, right? And where is proportional to P into R, and since P is constant now, where is only proportional to radius, right? Therefore, since where is proportional to radius, what means that when the radius is maximum, or when we are looking at the outer radius, where will be more, right? And when wear happens, pressure will be uh, pressure at the outer edge will be released, right? And since the pressure is now released, there will be no wear at the outer surface, okay? And the wear will now take place at the inner edge, right? And this will lead to further uh, release of pressure at the like, inner edge, and this cycle will continue. Where happens at the like, outer, the pressure gets released, and then wear will start to happen at the inner diameters, and then the loop will continue. This is how wear happens in friction plates. All right, then to summarize what we have learned about the torque carrying capacity, I've just listed the main points here. Uniform pressure theory is applicable for new touch plates when the friction lining is new, and uniform wear theory is applicable when the friction lining gets worn out, right? And the friction radius for new clutches is slightly greater than that of worn out. Okay, and the torque carrying capacity of new clutches will be slightly more than that of the worn out. Okay, and a like major portion of the life of friction lining comes under uniform wear, right? Because uh, immediately after service, once the wear starts, then the uniform pressure theory will no longer be applicable. We will have to rely more on uniform wear theory. Therefore, in design, it is more logical and safer to always use uniform wear theory to design the clutches. Okay. Therefore, the final formulas to be used in calculating the torque carrying capacity is: for uniform wear theory, we have derived that for uniform wear, the torque formula is mu p by 4 into d plus d. Now this formula we can like express it as mu p into Rf, where Rf is known as friction radius. Okay, and if you will look at this formula 11.8, we can say that the friction the radius RF is basically 1 by 4 times d plus d, right? So this is for uniform wear theory. These are the two formulas which we will be using like extensively. For uniform pressure, we will look into the next slide. All right, so looking into uniform pressure theory, you can simplify the formula given in 11.5 as mu p RF, and here the friction radius will be 1 by 3 times d cube minus d cube divided by d square minus d square, right? And uh, so this is the two formulas for uniform pressure. Okay? Also, if you will look at uniform wear theory, where the torque was given by mu p by 4 into d plus d, you can split it up into mu p into half of d plus 2 plus d by 2, which is the average, isn't it? This d plus d by 2 will be the average radius, right? Therefore, you can denote it as q me into rm, where rm is the mean radius, right? Therefore, from this formula, we can say that the torque carrying capacity can be increased by number one, increasing the coefficient of friction mu, or increasing the plate pressure P, or increasing the mean radius Rm. Right? These three factors will decide the level of torque transmitting capacity of the clutch. All right. Now, so far we have learnt about classification of clutches, functioning of a clutch. We have seen two videos, and then we have obtained, or we have derived the formulas for torque carrying capacity of a single plate friction clutch. All right. So after that, now we will start with multi-plate clutches or multi-disc clutches. I would want you to begin by viewing this video here. This is a video that is available in YouTube by Sharp Edge Global, which describes or shows you the animation of how a multi-plate clutch functions. So please go through this video and then uh, go through the remaining part of this presentation. All right, so let's look into multi-disc clutches now. This is the figure of a multi-disc clutch, a schematic of a multi-disc clutch taken from the Bandari textbook. Now, if you will see, this is the driving shaft here, and you have the driven shaft here, right? And you have you can see that there are splines on the driven shaft here, and you have two different sets of discs or plates here. If you can see, this three, one, two, three are disc B, okay, and you have disc A, three plates of disc A. Now disc A, you can see, is connected to the driven shaft, right? And there are four bolts also. Now this is a sectional view. You have a bolt one here, and along the circumference you will have four such bolts, and the bolts, you can see, passes through the holes in disc B. All right. So you will see, let's go through the material here. Uh, as I was mentioning, there are two separate sets of discs here. Disc A is made up of hardened steel, and disc B is made up of bronze. Okay, and disc A are mounted onto the driven shaft, right, through the splines. Okay, all right. Now let's see it further in the next slide. All right, so as I was like explaining in the previous slide, you have a bolt that passes through the holes on disc B, and since there is a clearance fit between the bolt and the holes in the disc, the set B can move in the axial direction, right? And the axial force P, you can see that there is a like force that is exerted on the disc, especially on disc A, through means of levers or springs. Okay, and this bolt, as you can see, is rigidly fixed to an external drum here, right? and since they are rigidly fixed, when the driving shaft will rotate, it will rotate the drum and the two disc set also. Thereby there is transmission of power. Yeah, so as I was saying, power is transmitted from the discs of set B to those of set A by means of friction, right? Therefore, there is a friction between the discs of set A, which is mounted on the driven shaft, and set B, which is fixed onto the drum, which rotates when the driving shaft will turn, right? Therefore, through this friction between the between the various contacting surfaces, the power gets transmitted. Alright, so having known how a multi-disk plate will function, let us look at its torque carrying capacity. The formulas remain same. The similar like equations which we derived for single plate friction clutch holds good here, except for one small change. If you will see here, for the torque formula for both uniform pressure and uniform wear criterion, there is an additional factor Z here, right? You will have to multiply both the formulas with Z, where Z is the number of pairs of contacting surfaces. For single plate clutch, it was essentially one. But now, since there are multiple pairs of contacting surfaces, you will have to multiply by the letter Z. All right. Now, how do we find out the number of pairs of contacting surfaces? Now, if you will look at this figure here, you have two sets of discs here. You have three sets. You have three discs belonging to set A, and you have two discs belonging to set B. Right. Therefore, you will have contacting. Uh, you will have four pairs of contacting surfaces between 1, 2, 3, 4, the 5 disks that is being used, right? Therefore, we can decide the number of contacting surfaces as follows. Uh, the number of disks that we will use will be equal to number of pairs of contacting surfaces plus 1. Okay? That is, in this figure, if you will see, we have 5 disks here, which will be 4 contacting surfaces plus 1, right? Therefore, uh, if Z1 is the number of discs on the driving shaft and Z2 is the number of discs on the driven shafts, then the total number of discs will be Z1 plus Z2, and this is equal to the number of pairs of contacting surfaces plus 1, right? Or finally, we can calculate the number of pairs of contacting surfaces as equal to the total number of discs that we use minus 1, right? If that is, it is obtained from this formula here. A number of pairs of contacting surfaces will be Z1 plus Z2 minus 1, right? We should also note that the two outer disk 1 and disk 5 here, have contacting surfaces on only one side, right? Okay. All right. So let's finally look at the difference between single and multi-disc patches. The number of pairs of contacting surface in the single plate clutch is one or at the most two, whereas there will be more number of contacting surfaces in the multi-disc. Right now, as the number of contacting surface will like increase, we will be able to transmit much more torque. Right. Therefore, for a given torque, the size of the multi-plate clutch will be much smaller than that of a single plate clutch. Therefore, multi-plate clutch will be more compact. All right. Now, moving on, the next difference is that in case because there is more friction there, more heat is generated in the multi-plate clutch rather than the single plate. Okay, therefore, because of this reason, you will very often observe that For multi-plate clutches, we will make use of cooling oil. Therefore, multi-plate clutches are wet clutches, whereas single plate clutches will be dry. Okay, and because of the use of cooling fluids, what happens is the coefficient of friction will decrease, right? And we know that if friction is decreased, then the torque that can be transmitted will also go down. Okay, whereas the coefficient of friction is very high in case of dry single plate clutches. Okay, therefore you should always go for an optimum choice. All right, therefore the final difference with regard to applications, you can actually say that single plate clutch, because it is dry and because it can transmit more torque, it is used in cases where there is enough space for it. If there is sufficient radial space for mounting single plate clutch, it is preferred. I mean, for example, in trucks and cars that we use, it is largely run on single plate clutches. Whereas when you need more compact mounting of the clutches, as in the case of scooter, we will make use of multi-plate clutches. All right. Okay. So with that, we come to the end of this presentation. I hope that you have understood various design aspects of clutches, and and there are plenty more animations and videos like available in online about clutches. Please go through them if you need it. And then from the next video onwards, we will start with solve problems on clutches. Thank you.